Good day, everyone, my audience and participants. I want to train you on a topic I titled Python application to Markov Chain Prediction for Forex Markets, Naira Dollar Exchange Rate Dynamics. Before we start the training, let me just introduce myself. My name is Dr. Ajibola Arewa. I lecture in the Department of Finance, Lagos State University, Nigeria. So in this training, you'll be learning how to predict forex exchange market using Markov Chain Algorithm. Now, the outline for this training is: first, we have the concept of Markov chain. 2, the assumptions, properties of Markov chain. 3, basic elements of Markov chain or basic components of Markov chain. 4, types of Markov chain. Number 5, short run versus long run Markov chain forecast. Number 6, numeric examples of short run and long run. Then number 7, that is the practical application of Python in forecasting forex market based on Markov chain algorithm. And in this practical section, we build a matrix and interpret. Then we do the short-run forecast as well as the long-run forecast with their corresponding simulations. Now, let's start from the concept of Markov chain. Markov chain is a stochastic process or a stochastic method that models the trajectories of events, in which case the future event depends on the current event and it does not depend on the future event. In Markov chain, we are saying that current event only depends on the future events only depends on the current event, and that it has nothing to do, it does not have correlation. Future events does not have correlation with the past event. The future does not have the memory of the past. Once we are in the future, we have forgotten everything about the past. We can only trace our path to the current. After the current, we don't know anything about the past. That is the basic assumption of Markov chain. Let's think about a stock market. In a stock market, Markov chain assumes that tomorrow price depends on today's price, and next tomorrow price depends on tomorrow price and not today's price. Then let's look at the mathematical expression or mathematical definition of Markov chain. It is a probability model. It is a probability model that is expressed as this. In this expression, in this definition, we can simply explain this to a layman. It means that the probability that the system will be in state X at time t plus 1, given the historical antecedents, is equal to the probability that the system will be in state X at time t plus 1, given the current antecedent, the current event. The system here can be in a market, can be an economy, can even be an institution. Now, to buttress on this point, to expand what we are saying, we have a very good example here, the finite example and the infinite example. The finite example is where we know the numbers of events. And then the infinite example is where the numbers of events is not known. Now let's look at the finite event. In the finite event, we have xt moving to influencing xt plus 1, then st plus 1 influencing xt plus 2, st plus 2 influencing st plus 3, till we get to st plus n. This simply means that event at time t plus 1, as the future event at time t plus 1, depend on the event at time t, the current event. Why the event at time t plus 2 depends on the event at time t plus 1 and not on at time t. Then the event at time t plus 3 depend only on the event at time t plus 2. It does not depend on the event at time t plus 1 or on the event at time t. The arrow simply means that only depend on. This is the conceptual framework of Markov chain. Then let's proceed to the next outline for this training. The next outline is the assumption of the Markov chain. There are about seven assumptions. The first one is the discrete state space. Discrete state space. This simply means that the system passes through definite finite state, countable or uncountable infinite state. The system evolves through a specified numbers of state. Let's have an example of a student who is just enrolled into a university. Such student will go through 100 level, that's the first state. Then from 100 level to 200 level to 300 level, probably to 400 or 500 level. These are the states available for the student to evolve. Now, if we talk about the market could be at a particular state in bullish, or at a particular state in bearish, or at a particular state being stable. Then the second assumption, which is the most important assumption of Markov chain, is the memoryless property. This assumption states that the feature only depends on the current. It does not depend on the past event. The future event only depends on the current. It does not depend on the past event. We cannot predict the future from the past, but we can predict the future from the current. That is what it means. Now, the third assumption is the time homogeneity. The time homogeneity assumption says that probability is invariant. Probability is constant over time. The probability of transiting from one state to another state is constant over time. The probability of moving from state J to state I is constant over time. Take for example, if it will take a system 10% to move from a particular state to another state at time t2, then at time t3 it will also take that system 10% to move from that state to the other state. So the probability would not change, does not change over time. And that's what we call time homogeneity assumption. Then the fourth assumption is the stationary distribution. Stationary distribution. That means that it is assumed that there is log-run equilibrium. There is existence of log-run equilibrium. That means that the system stabilizes at a stable path after a long time. For example, if we have three states like up, low, and stable, there could be the chances that the system will stabilize in the upper state at 70% chances or probability, then 20% chances of stabilizing at the lower state, then 10% chances of stabilizing at the stable state. Mathematically, this expression can be expressed as pi p is equal to pi. That is, probability stabilizes after a long period of time. The next assumption is called irreducibility. Irreducibility. That means that after the initial stage, the system can reach any state from any state. You can move from state 1 to any other state. The system can move from state 1 to any other state. And that means that the system is irreducible. The possibility of moving from any state to any state is called irreducibility. Then the next one is a periodicity assumption. A periodicity assumption simply means that the system does not follow a strict or a fixed cycle. It allows random or irregular cycles, e.g. 2 days, 3 days, 5 days, and so on and so forth. The system return cannot be regular. It's assumed to be irregular. Then absorbing state assumption. This assumption simply means that the system gets to a particular state and stay there perpetually, like the bankruptcy state. It can get to a state and get stuck. The system can get to a state and get stuck. And that's what we mean by absorbing state. Now, we now move to the main components of Markov chain. The main component of Markov chain, there are three. We have the states, we have the transition probabilities, and the transition matrix. The state is referred to all possible positions or conditions that the system could pass through. For example, in the stock market, the system could pass through bearish, could pass through bullish, could pass through being stable. These are the states that the system can pass through in the stock market. Now, let's look at the transition probabilities. These are probabilities of changing from one state to another state. They are the chances of moving from low to high or from high to low. Now, transition probability, this is a square matrix of all the transition probability defined as P subscript ij is equal to P bracket open x t subscript t plus 1 is equals to j. The condition on st is equals to I. That means that the probability of moving from state J to state I. Then it means that the transition matrix is a matrix of probability transition elements. Types of Markov chain. The first one we have here is the finite and infinite Markov chain. We have the regular, we have the absorbing, and we have the continuous time Markov chain. Then the finite Markov chain. The finite Markov chain simply states that the numbers of events are known. The numbers of states are known. Then the infinite is a situation where the numbers of states, the numbers of events are not known. For example, if the stock market moves randomly up and down by 1 naira or by $1 within a day, it is infinite Markov chain. The regular Markov chain. The regular Markov chain shows a system where it is possible to reach any state with positive probability. After the first step, that is, as from second step, there is positive probability or chances to reach any state. In stock market, we know we call it sticking prices. Stock market, we call it sticking prices. No sticking prices, please. In stock market, we say no sticking prices. No sticking prices. And what does that mean? It means that there is positive probability of changing from one state to another. That is what we call regular Markov chain. No sticking prices. Then we look at another type of Markov chain that is called absorbing Markov chain. This is a Markov chain where there is possibility that the system gets stuck at a state indefinitely. I think I've explained this. Then the next one, which is the last one here, is the continuous time Markov chain. In the continuous time Markov chain, the changes of the transition occur at any time. When changes or transition occur at any time, no specific time, it can occur at any time. We call it continuous time Markov chain, not at a specific time. For example, stock prices can jump at any time. It can jump every second, it can jump every minute, not a specific day, not a specific year. And this is also called continuous time Markov chain. Then these are the types of Markov chain. Then the next one we are going to look at is the forecasting Markov chain. Forecasting Markov chain, or forecasting with Markov chain. Forecasting with Markov chain. When we want to forecast using Markov chain, it can either be short-run forecast or long-run forecast. So let's look at the long-run forecast versus the short-run forecast. Let's take the short-run forecast first. In the short-run forecast, we are simply saying that you can forecast tomorrow from today. That means that tomorrow depends on today, or next tomorrow event depends on tomorrow event, and that is what we refer to short-run forecast. But nevertheless, when we are talking about forecasting using Markov chain, we are not actually forecasting or predicting values or prices. Rather, we are predicting the possibility, the chances, the probability that a system or a market will move from one state to another, from one event to another. So actually, we are predicting possibility, we are predicting probability, but not values. So in the short run, we predict the possibility of changing, probability of changing the event of today or the event of tomorrow based on today. Now we have, how do we implement the short-run forecast? This is relatively simple. There are stages that are involved when you want to implement the short-run forecast. Like I defined the short-run forecast, I said the short-run forecast is when tomorrow's price depends on today's price, future depends on today. Short-run. And to implement this numerically, let's look at it. Let's look at the structure of the model before we look at the numeric examples. Now, the first thing is to define the state. You must have your state. Now, state 1, state 2, state 3 to state n. This means that the states are known. Up, down, stable. High, low, stable. These are the states. These are the bands that prices can be classified. So we can have low band, high band, or stable band of prices. Then in our economy, we can have recession, we can have stability, and all of these form the state that we can experience in an economy. Then after the state has been defined, or after the state has been known, then the next stage is to define the transition probability. And this is transition probability, in which case it is a square matrix, the column and the the rows are equal. So we call it a square matrix. Then after that, we now have, after the matrix, the next thing is to multiply the initial vector. This initial vector. So we multiply the initial vector by the matrix. Initial vector by the matrix. That if we do that, we now determine the probability of transition in step 1. Then after that, we now multiply the initial vector by the probability square, and that determines the probability of transition in step 2. It continues like that until we get to step n. Then that is that. Rather, if we have n period of forecast, so the initial vector, then to get to the probability of transiting in state 1, we multiply the initial vector by the matrix, transition matrix, and then to get to the stage 2 ahead prediction, we multiply the initial vector by the square of the transition matrix. We continue like that until we get to the numbers of period ahead that we want to predict. Now, look at the numeric examples we have here. Here we have 3 states, I, M, H. And this is a low, middle, or moderate, and high. Low, moderate, and high. These are the states that we can experience in an economy or in a stock market. So the X is labeled, the state is labeled low, medium, and high. Now, this is the transition probability we have here. So this transition probability is an assumption that the probability that the state will be in the same loop. Low to low is 40%, low to medium is 0.5%, then low to medium 50%, low to high is 10%. If we add the probability together in a row, it should give us 100%, or it should give us 1. Now, we have the initial vector. Since we have 3 states, the first state is low, then the second state is moderate, and then the last state is high. So actually the first state will be 1. That is mean that there is at the initial time there will be 100% possibility that will be in the low state. And then after that, we now use that vector to multiply the probability so that we move to the step 1, prediction ahead. When we multiply, we have this. That means that there will be 40% chances of being low price, 50% chances of being moderate price, and 10% chances of being high price. And then we continue like that. The next state, that will state 2, we use the initial vector to multiply this probability raised to power 2. Then we continue until we get to the last period ahead prediction. And that's what we call the short-run forecast Markov chain. Then the long-run forecast Markov chain. In the long-run forecast Markov chain, it tells us where or which state the system will spend most of its time. Which states, where the system, the market in the stock market, the economy in an economy will spend the most part of its time. If it keeps on running for a long time, it does not deal with what happens in the next time as we have in the short run. No. But it tells us after a long running, after a long time, how the system will stabilize. But rather it reveals the long run behavior of a system. Now we have the distinction between the short run Markov chain and the long run Markov chain as we have here. These are the differences between the long run and the short run. Now, let's quickly look at the long run. Let's look at the long run. How do we implement the long run? Manually, let's assume that we have the pi is equal to pi multiplied by the probability. Now, where the summation of all the pi must be equal to 1. And then the pi is the steady state vector. In this case, pi is a steady state vector. Because in the log run, we assume that there is a steady state. So pi is a steady state vector, while the probability, the P is the matrix or probability matrix. That is the matrix of probability transition. Now, assuming that we have two steady state, pi 1 and pi 2, and then we have the probabilities, 70%, 30%, 40%, 60%. We simply multiply the state vector by the probability. And we have these two equations, these two system of equation, and then we'll add 1 to it to restrict the probability to be equal to 1, like pi 1 plus pi 2 is equal to 1. Then we now solve the system of equation. And if we solve the system of equation, we get pi 1 to be 50% and pi 2 to be 50%. And that means that there's probability that the system will spend 50% of its time in state 1 and 50% of its time in state 2. So this means that 50% of the time the stock will be low if it is low, and also 50% of the time the system or the stock market will be high if the first state is low and the second state is high. So we can easily compute this manually. But by the time we have a market, and then we want to apply this practically for a long period, computing this manually may be cumbersome, sometimes so strenuous and difficult. And that is why we recommend that in such instances, somebody can use Python or R. These two programs or software are highly recommended. Now, how do you use Python application? So the next line for our discussion is Python application. So how you can use Python application to implement Markov Chain Algorithm. Now, we'll start from the short run. Then how do we build the transition matrix? Now, I will end this video here for now. We continue this video from video 2 on Python application to foreign market prediction. The one I've just done now is video 1, V1. So we start from V2, video 2 on Python application to foreign market focus or foreign market prediction. Thank you for listening to me, and I will employ you to also watch the second video that will come up immediately after this. I am Dr. Ajibola Arewa, and I lecture in the Department of Finance, Lagos State University. I'm an expert in financial econometrics, financial modeling, and asset pricing. Thank you very much.